So in continuation with the parallelism, right? So we already discussed about parallelism. So why we have a parallelism, in Abinitio, like the different kind of parallelism to enhance the performance of the job, right? Or Abinitio graph or plan. We have, kind of parallelism. There are parallelism called component parallelism, pipeline parallelism, and data parallelism. So how we use the data to process, where we are going to process the data, and what are the how we design the graph. So these are the principle, right? uh, these are the principle wherein these parallelism comes into picture, and they try to process data as efficiently as possible. So when we talk about component parallelism, right, so how the component parallelism is getting introduced into the graph. So what we can do is, let's say we have a flow of data, you know from the input we are receiving the data into the reformat component, and these are the flow, like, and there is a target, right, in output file. This is the simplest graph from input, reformat, and the output. But for certain activities, let's say we have to have two flows, right, after reformat or before reformat. So what we can introduce is, like, after reformat, we can introduce a replicate component so that it can create a parallel similar flow, so that the data from the flow can go into the either both the direction, right? If you use the replicate. So in replicate, right, let's design one file. Let's say, okay. If I have, so this is my replicate, let's say. No, I mean, this is my component. Okay, let's say this is my replicate component. Okay, this is my data coming in. My data is coming in. Okay, here. If I introduce a replicate, so I can create two flows, right? Like this, and I can create like this. So if I receive 8 records here and replicate, okay, this is my replicate. Replicate. If I receive 8 record here, my 8 record will go to here, and also the 8 record. So this will be a duplicate. I mean, the same replication happen, the data. So because we created two flows from the same single flow, so this is my component parallelism. So using the component, I have enhanced the parallelism so that this data can be processed in parallel. So at the same time, this data will be processed by this component. Let's say it's a roll-up component, and also here, let's say it's a join component, and it is getting joined with another flow, right? So these activity can happen parallelly, right? So therefore, it is enhancing the data processing uh, capacity, and also it is getting introduced by the replicate component. Similarly, in input file, right? In input file, let's say this is my input file. Okay. So in input file, I can connect as many output flow as I want. There is no limitation. So this also increasing the flow. So all the flows can read the data parallelly from the source, this input file, and also can put into the another component. Let's say here I'm reformatting. Here it is in a roll up component. Here it is in a scan component, right? So if these are the three things, then input file also is some kind of you know enhancing my component parallelism. And then there is a reformat. So let's go up. So if it is a reformat, so there are parameters like count. If I have two counts, so I can create two flows, two output ports. So I receive the at records. So let's say based on the if I have any condition that I can specify in my output index or indexes, there are two to those functions. If I don't provide any output index or output indexes, then 8 record would go to here, 8 record would go to here. So this is also enhances the parallelism, component parallelism, because it creates two flows. So and this component is used to enhance the parallelism, which is called a component parallelism. Similarly, filter by expression, right? I have a filter by expression out port and unselect deselect port, right? This is deselect port, this is the output in filter by expression. Similarly, partition by expression. So depending upon different if else statement, I can create the flows from the partition by expression. Depending upon this expression, which is there in this one, I can create the different flows as many I want. Then dedupe sorter. So like dedupe sorter, we will have like I have an output port and I have deselect or unselect something, some port is dedupe port. I think second port is called dedupe port. This is called output port, right? So we will have two flows. This is also enhanced the this one. Split is like uh, based on your DML output DML. You split the data. So let's say I have XML to process, and I want my one of the node in go into the in 0 out 0, one node go into the out 1 and one node go to the out 3. So the split component is also enhances the component parallelism. So then there is a gather these are the so these are the DN, this is enhances the component parallelism, but it try to uh, reduce the parallelism. It's gather. So from multiple flows, my gather can collect the record. So therefore, it creates from multiple flow to the single flow it creates. So therefore, it is called a it can reduce the component parallelism. Similarly, join, let's say it can reduce the two or more flow into the single flow, right? Then combine, fuse also same, two or more flow, right? And there is one flow. Combine also there is an two flow, and then target is one flow. Concatenate. So concatenate is right. If you want to concatenate the data from header trailer scenario, right? So we want to concatenate the header, then data, and then trailer. So this concatenate will be used to reduce the component parallelism. So these are the different parallelism, component parallelism that we can think. These are the different component which enhances the component parallelism, also try to reduce the component parallelism. So depending upon the design or requirement, we pick and choose the component so that we can try to process the data parallelly. Also we can utilize the parallelism concept, and also we can design our graph efficiently. So similarly, let's say pipeline parallelism. So what are the different components? When we talk about pipeline parallelism, the things comes into picture is like my in single flow, my first component is getting processing one of the data, and my downstream components also in parallel are processing the data. So let's say in this design, right? So this is my reformat, and this is my roll up, or maybe I could say scan component, right? The data is sorted or something like that. So there are 5 records, let's say. My fifth record is getting processed by this one, reformat component, and my fourth record is getting processed by scan component, and my third record is getting processed by some other component here, right? If those are the records are getting processed by multiple component at the same time, so that is called kind of pipeline parallelism. So data is in pipeline basically, right? So fourth record, fifth record, second record, first record, right? So these are all can process in parallel basically, let's say, and then we can put the data into the output file one by one. I mean, depending upon the processed thing. So if one is processed, put into the output file. Then after some time, second, third, second, fourth, fifth, right? So the sort component, right? What sort component does is it try to sort the data. So it has to have all the information, all the data in one time, so that it can try to apply the sorting algorithm. To apply that algorithm, it has to have, all the data basically. So to have all the data basically in the sense of it hold up the record, because it hold up all the record at one place. So if everything is done by the sorting algorithm, then only the record will come out. Therefore, it is reducing the pipeline in parallelism. Similarly, in rollup also. So rollup, right? If it is not a, even if it is a key based also, it, if you have applying the, sorted data, and this is a key, there is a key K1, you are giving the sorted data. Even then, to process the group, right, it should wait for entire group, it should wait, and then it will process the data. So somehow this rollup is also is an hindrance, or is a, reducing the pipeline parallelism basically. Okay, so it has to have, all the records, then only try to group the records, right? So as soon as the group is, it knows that the group has been done, because in case of sorted data, it is, if the key changes happens, then the previous key data has been received, and the rollup can process the data into the output. Otherwise, it try to wait if there is no, sorting applied, sort does itself internal sort is applied, then, you know, it try to process all the record at one place, and then try to send the record group wise to the output or downstream. So, and also the join component. So that join will wait for the, keys in this, override port, or in the IN0, let's say IN1 port. As soon as all the, it 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 knows, as soon as it knows that all the keys which I am looking for, has been searched in the another port, then only the data would flow out, right? So this join sometimes, it also try to reduce the pipeline parallelism basically, and dedupe sorted also, because something is related to sorted means, it has to have the information of all the records at one place, right? In reformat, so reformat is simple, because data comes and, put into the output, or scan, right? Data comes and put into the output, right? And the normalize. So these are the different components, right? They are not, they are, helpful in, enhancing the pipeline parallelism basically. So then we have phases and checkpoints. So if we try to create the phases in the sense of, if we want to utilize the memory and the CPU cycle efficiently, right? So in those cases we use the phases. So portion of the graph we process in one phase, and then rest of the portion of the graph we process in second phase, and so on, right? So this is how we try to, try to process the records and the checkpoints, right? Checkpoint in the sense of the data would land up in the that place actually. And the component folding. So other day we were talking about the component folding, right? So the similar components can be joined together to create, one process basically, rather than creating a separate flow, separate part of processes. We can create the single process for the group of components, right? So that you can explore when we talked about component folding in another video. And there is a continuous graphs also. So when I was talking about in other videos, like with respect to continuous graph, I talked about checkpoint and compute points, what they are. So in those cases also, there are places where checkpoint is reducing the pipeline parallelism, then the compute points. So we introduce the multiple compute points within the checkpoint, so that the parallelism, pipeline parallelism, we can utilize that. So then there is a data parallelism, right? Data parallelism can be achieved in multiple ways, right? So multiple ways in the sense of, like, so there are, so before understanding the data parallelism, so we place the data into the different nodes, or different file directory, or a different uh, different files within a single directory, right? So so that the data can be segregated in different places, and the data can be processed. So we need to understand what is the data layout and what is the processing layout. So the data layout is where the physical data is landing, right? The processing layout is when the any component is getting processed, the temporary files and all, the place where all those temporary files, work directory files, and all those files getting placed is called a processing layout. So in case of serial files, and we are sitting in the, let's say, Linux node, so when we try to so these are the not different things, data layout and processing layout, right? So they are kind of same. So if we are processing within a rollup, and we are reading the data from input file, and there is an rollup, and then there is an reformat, and then there is an output file. So the rollup and reformat would try to utilize the the layout which is similar to the input file or output file, right? Depending upon the context in where it is getting connected, whether we have partitioning or not partitioning, so then we can try to propagate the layout, those kind of things. But in case of if we are working with the SDFS or cloud, so what we can try to do is we try to keep the data layout is similar to the cloud URL, but processing layout we will keep using the nodes where Abinitio is installed, right? So that the input, the file system input output is less, right? So that it can process. It should not be writing the data into the cloud, because it try to write the data into the cloud, and then if graph fails, and then it try to recover those graphs, right? So in those cases, the turnaround time, or it's going to be very high. In those cases, we try to utilize the processing layout where Abinitio is installed, but the data layout can be used from SDFS or a cloud system, right? S3 bucket file path. And then there are the serial files, then there is a multi-files, and then there is ad hoc multi-file files. Ad hoc multi-file file in the serial file, but there are multiple serial files. Basically, we can jointly can create, and we can create the ad hoc multi-file system from our side, right? Those also can be done. Then there is one more concept is called a dynamic layout. So we are going to talk about this dynamic layout in other video also, but let's me touch this dynamic layout here. So in the process of like Hadoop processing, you know, and the containerized graph, right? The Kubernetes container, right? So in those environments where multiple VMs are there, virtual machines are there, or also we are processing the data in the cloud environment where multiple nodes are getting into picture. So in those kind of places, we need, and our graph needs to be running in those kind of environments. So what we can do is we can create the dynamic layout. We are not going to fix the layout. The layout is going to be determined at runtime, you know using the operating system at runtime will decide the layout, the actual depth also. Sometimes variable depth, if we assign, then the depth also would be decided by the operating system and the resource manager. So and the which layout, which which multi-file system, or which layout is it is going to use, also would be decided by the operating system then. Okay, in those kind of places, so the thing is like the idea behind this dynamic layout concept is like we try to utilize the same graph, into the different environments basically. So let's say we are creating a graph for one machine, let's say one node machine or two node machine, but the same graph in production is going to be utilized by the multiple VMs, or the in the Kubernetes, or those kind of environments it's going to be used. So we can just create the dynamic layout, okay, and the layout in development we can assign just one, and in production when the resource manager and operating system comes into play, they will decide that which dynamic which layout they are going to use. So to assign this layout, we use the m file colon dynamic and the depth of the parallelism. So these are the this is how we assign this dynamic layout. This is 16-way depth. Okay. So whichever resource is available, it is, because in Kubernetes kind of environments, right? We don't know what machine is going to be executing this graph basically. So for this time, this another X machine is running this graph. Otherwise, in next time, some other machine may be executing this kind of this graph, right? The same graph. So in those kind of environments, we use this one. Here also variable depth. So there is a fixed depth. I said 16, right? Depth of parallelism 16, but there could be a variable depth also. This also can be decided at runtime. So if we assign -1, then and we can assign the maximum depth actually. So if I said 16 and -1 I said, then depending upon the availability, the graph can be running dynamically at the depth of 8th also, or maybe 14 also, or maybe 16, not more than that. So max depth we have fixed it, but the it's a dynamic actually. It could be 4-way, 2-way, 8-way, right? That kind of things. That kind of flexibility we could have in variable depth dynamic layout, along with the layout also with the depth also. So this is the detailed discussion about the parallelism concept, right? Data parallelism concept with respect to any environment, whether we have a single node machine wherein cooperative system is installed, or whether we have a Hadoop based machine, right, or we have a cloud based machines wherein multiple VMs are utilized by the Kubernetes resource manager, right? Containerized applications basically. So with that, thank you so much. Please subscribe my channel, and we are going to see multiple more videos on this kind of concept and other advanced concept with respect to Ab initio and AWS. Okay, thank you so much.